Yeah, welcome students on another lesson. So now we'll be dealing with what do we call conti. We'll be dealing with what do we call the contingency table. The contingency table. Well, contingency table is a table which is just simpler, which is just easier to interpret, right? Only if you just simply you listen to me and then you grasp what I'm about to say, right? So what happens is that we have a table of this sort, right? Here I'm just going to generate an equation for you to be able to, to understand, right? So here I have event A, and then here I have event B. Just simply know that the first column represent what? Your events in this case. The first column represents your events. The first column, I said the first column represents what? The first column represents your events. Right? So let's make a scenario. I'm just gonna draw just a simple thing. So here we have gender, and then we can have males or females. Right? We have males or females. And then here we can have what do we call a class, right? So either class A, okay, here we'll have total, right? And then here the first, okay, here we'll have under class we'll have, here we'll have class A, here we'll have class B. So A represent this column in this case, and B represent this column, right? So we have two different classes and we have two different genders. So I want you to know that in this case we have two different events. So my gender in this case represents event A, and then my class in this case represents event B, right? Suppose I have A, I have B, I have C, I have D, I have E, I have F, and I still have another column. I still have what? I still have another column for what? For for the totals. I still have another column for for the totals. So I have A, I have B, I have C, I have D, I have E, I have F, I have H, and then let me just simply choose any random. I have Z, I have Y, right? Note that this, just simply note that these variables or these alphabets in this case, they represent numbers, right? They're the constants, so they represent what? Numbers. So meaning here I'll have A males, so A represent the numbers, right? So what if I, I were to say determine the probability of finding males? Here's the question, right? And what if I said the probability of finding a male who's in class B, right? And then what if I said determine the probability of a male who's in class A and determine the probability of females, and then in this case I say determine the probability of a male, determine the probability of a female who's in class A, or the probability of a female who's in class B. Now let's start with the first one. The first one, we want the number of males, not the number but the probability of males, right? So what do we have? I want you to note that here we have the total, right? This is the total for this row, the first row. So adding A plus B is equivalent to what? To H, right? We know that A plus B is equivalent to to H. The same thing applies to this total which is Z. So this total which is Z, it is the sum of C and D. So when I add C and D, I get Z, right? So this is the total of this row. And then the same thing applies with Y. Y, it is the total of this row. When I add the total number of learners from class A and the total numbers of learners from class B, I get Y. So you have to note that A plus B is equivalent to H, and the same thing in this case, C plus D is equivalent to Z. And the last one being that E plus F is equivalent to Y. So it's simple. We know that here is H is the total of the first row when we add A and B, and then Z is the total of the second row when we add C and D, and Y being the total of the last row when we add E and F, right? So we know that this Y, what is this Y? Y, we know this Y is equivalent to E plus F, and it is also equivalent to H. So if we add H and Z, we will get Y. So just simply note that the total of this side is equivalent to the total on this side. So Y is still equivalent to H plus Z, right? So suppose on the first equation, so let's say we have A, B, C, D, E, and F, right? On A, we have the probability of males. So we want the males. We never classified whether we want the male from class A. Like I said, this is column from, this is class A, and this is class B. We never specified whether we want the males from A or B. So what do? We will take the total number of males, and the total number of males, that is the total of this row, right? Which is A plus B. A plus B, we know in this case is equivalent to H. I'll have H over what? Over the sample space. The sample space is our total. The sample space is what? It's Y. I will have H over Y. Just simply note that Y in this case is our sample space or sample size in this case, right? And the same thing applies with the second equation. Now in this case, I want a male. So you check, we want a male. You check the row for male. The first thing that you do, we consider the row for male. Which male? I want a male from class B. You will say, okay, here's male. Which class? We have class A and class B. Now I want the probability of attaining a male from class B. And how many learners are there in class B? We have B learners. So B represents a number. Do not forget that B represents a certain number that we don't really know about, right? So we know that we want a male who is in class B. So we'll have B. So that's B over what? We'll have this B simply stands for a learner who is a male and is from class B. So we'll have B over Y. Right, the same thing applies whenever we have male. Now this is male, right? We want a male who's in class A. So this is class A. So we have A learners in class A. We have A male learners, right? So we'll have A over the total, which is A over Y, right? So we are looking for the probability of attaining females. We never classified, like I'm quoting, we never classified, right? So we take the total number of females. So Z is the total number of females because we said Z is the total number of this row, and this row we know that it represents the females. So we'll have Z over Y. Right? The same thing, you do the same thing over and over. Right? Now, one may ask themselves, Peter, why are you doing these things? I'm just simply repeating the same thing uh, again and again. I'm just simply doing this because I want you to grasp this, right? And this is a sample version of our equation. there was this moment I just had to sit, design my own equation on this contingency table just to make it simpler. By just simply grasping these steps, everything's done, right? Everything is done, right? Now let's do what? Let's attempt some few questions so that you get to see the application. I don't wanna bore you too much with the theory, but let's apply and see where it leads us. Right here we want maths, right? And if you check, we never treated a whole question paper, because what do? Right? We look at certain sections in a sequence, right? So at the end we'll be able to treat an entire question. So it's either on the question you're going to have a Venn diagram, or a proper or a Venn diagram, or a tree diagram, or a contingency table. So one of the three is going to appear, either your test or exam, right? So one of the three is going to appear. Just simply know that, right? That's why I want you to grasp all of them. Right? Now let's look at a question which includes contingency table that we can solve, right? So I know this one, but I'm just going to start with like a softer one for you, just to, you see. Yeah, let's do, okay, we'll do this one at a later stage. Let's try to find another example. Let's try to find another example. If not, we'll just have to deal with them. Okay, now we are given, now we have question 30. Now let's look at the question 80, right? Question 80, we are given a contingency table, right? We are given a contingency table. Forgive me, I'm just gonna try to draw it for me to be able to have a full page, because I want the space to be able to write the solutions. Now in this case, we are given what? We are given a contingency. We are given a contingency table, right? So this column is HIV positive, this one is HIV negative, and then we have the total. Here we have B, we have C, we have 960, we have D, we have E, we have 422. I'm just copying the question. And then we have 106. Okay, then we have, here's 106, and then here we have A, and we have 192, right? Are we done? Okay, now we can have a full page. Now the first question, which is 13.1, we are required to determine the values of A, B, C, D, and E, right? Now the first thing that we do, now we follow the same procedure, right? I've generated a simple formula for you, right? The first thing that we have to know, we know that, okay, B is the total of what? We know that B is the total of these two blocks, right? Which means 106 plus 422 is equivalent to B. This is something that we did in the first, right? And then we know that the same thing applies here. We know that A plus D is equivalent to C. And we know that 192 plus E is equivalent to 960. And I told you that you start with the one that has a single variable. Now we already know that the B is equivalent to the sum of the two. So let's add them. 106 plus 106 plus 422. What is 106 plus 422? 106 plus 422 is 528, right? And then we have, this consists of three variable. You just simply wait a bit, right? and then we look at the one with a single variable. So I know that I'm looking for E. I'll transpose 192, right? I'll have 960 minus 192. So 960, okay, 960 minus 192. That's 7, that's 760, 68, right? And the same thing applies. I know that, okay, I was able to attain, I was able to attain, in this case, E, right? So E is 768, right? And then the same thing applies here, right? The sampler, the same thing applies here. I want us to, okay, and the same thing applies here. So we said these are the total of these rows, yeah? Then we said these are the total of this row, and these are the total of this row. Now E and F, just simply know E is the total of the whole of class A. So that is the total number of the learners in class A. So that means A plus C is equivalent to E. That simply means that in this case, A plus C, we're saying A plus C, A plus C, A plus C is equivalent to E in this case, because E is our total, the total of this column, right? So in this case, we know that E plus E is equivalent to what? E is equivalent to A plus C. The same thing applies with F. We know that F is the total of this column. We know that F is what? We know that F is equivalent to B plus T. Right? Now let's go back to let's go back to let's go back to our question. Let's go back to our question, right? So we know that 192 is the total of this row, right? So that means if I add 106 plus A, I'll be able to get 192. But I'm looking for A. What do? I transpose 106 to the other side. So when I transpose 106, it becomes negative 106, right? So what is 192 minus 106? That's a 6. So here you have 86, right? The same thing applies here. You have HIV, right? So we know HIV negative. We know that 422 plus D is equivalent to 768, right? So what do? You isolate D, and then you will have 768 minus 422. So what is 768? What is 768 minus 422? So 768 minus 422, that's 346. So you are already done. You were able to determine D. So now we have the value. Did we determine A? So we have the value of A, right? We have the value of B. Okay, we have the value of A. We have the value of B. So we are only left with the value of C. And we know that C is the sum of A and D, right? So I know that when I add 86 plus, what is D? Plus 346, I attain C. So what is 86 plus 340? 346. That's 432. That's 432. I know that's my C. So I was able to find the value of A, the value of B, the value of C, the value of D, and the value of E. Now I'm done with the first equation. I'm done with the first question by using our equation. So I'm already done with the first equation, right? Now let's go back to the question, right? So we are done with 1.3.2, right? And then 1.3.1, it's as follows. 1.3.1, okay, this was 1.3.2. We were asked to determine the values of A, B, C, and D, right? And then 1.3.1 reads as follows. How many students are there at the college. So how many students are there at the college? The moment you see this, how many students are there at the college, we already know that they're speaking about the sample space, right? Or the sample size. What is our sample size? Our sample size becomes the total. You see, the sum of this, thus we have the total here. The sum of this is still, it remains to be 960. So the total learners that are there in at the college, it's 960. So for 9.31, we have we have 960 what? We have 960 students. We have 960 students. We have 960 students, right? Now, here's a question. Question 13.3. This is a real question. I've been waiting. So now this is question, which is 13, that's 13.3, right? So is HIV status independent of gender at this college? So is what okay is HIV status independent of gender at this college? So what they are trying to ask you is whether the two events are independent or not. Is whether the two is whether the two events are independent or not, right? So we know the first events that we have, it will be gender, and the second one is HIV status, right? So the first thing you state, right? You state the condition, right? You will state the condition, and you will say for indie. So for independent, events, the probability of A and B is equivalent to the probability of A multiplied by the probability of B. So this is where we deal with the independent events, right? So we know that the probability of A and B is equivalent to the probability of A multiplied by the probability of what? Multiplied by the probability of B, right? So the question is as follows, right? We know is HIV status independent of gender, right? So here's what you're going to do. You are going to choose, right? You are going to choose from the table. You are going to choose from the pies. Either you choose a male or a female who's either positive or negative, right? So here you are not restricted, right? You are going to choose from the column. Now I want you to note right? So the first thing that you're going to do, you are not restricted, right? So the first thing that you're going to do, you're going to choose you're going to choose at least one block from this event from the female, and one block from this from from the HIV status, whether it's positive or negative, doesn't care, doesn't matter. And the same thing here, whether it's positive and negative, it doesn't really matter, right? So I'm going to choose a male who is HIV negative. I choose, you can choose whatever you want to choose, right? You can choose, at least you have to choose, like you are supposed to choose one from gender and one from the HIV status. Looking at the gender, I'm going to choose a male, and then the HIV status, I'm going to choose a male who is, okay, I'm going to choose a male who is HIV negative. Now I choose male, and I choose the male who is who is HIV negative, right? The first thing that I'm going to determine the probability of a male who's HIV negative. So this is the probability of a male and HIV negative. So what is the probability of a male who's HIV negative? I'm going to look at the common form. I'm going to look at this row, right? this row of males, right? So what do I do at this row? I want a male who's HIV negative, and here it's a male who is HIV negative. So I'm determining the probabilities. So I'll have 4 2 2 all over what? I'll have 4 2 2 all over 960. I'll have 422 over 960. Let's calculate it. What is 442 over 960? That's 211 all over 48, right? So the same thing. Now I want you to note the first thing that we consider and, right? So I choose a male who's HIV negative, and I determine the probability of a male who is HIV what negative. It turned out to be 211 over 48. Turned out to be 211 over 48, right? And then now I'm going to look male only. I'm going to look at male only. I'm going to look at the probability of attaining a male. Male what only? So how many males do I have? I look at the total number of males, and I know that the total number of males is B. I know B is 106 plus 422, and we were able to find it in the previous question, right? So we said 106 plus 422, which turned out to be 528. So we will have 528 all over 960. We'll have 528 over 960. So what is 528 over 960? That is 11 over 20. That's 11 over 20. Right? Now the same thing that we do, we chose the entire males, right? Now I will choose the entire what? Negative, right? Now I'll choose for HIV negative. I choose for the whole of HIV negative, and I know that the whole HIV negative is this column, right? So I want the total number of those who are HIV negative. I don't care whether it's a male, I want them, the whole of them. So what is E? So let's go and find the value of E. We were able to determine it in the previous question. Oh, even for E, we can find it now. We can say 960 minus 192 to get E. If you don't want to do this, you can go. We've determined it in the previous question. So 960, that's 960 minus 192. I just want to go back. I just don't want to go back to that slide so that we save time. We have 968 over over 960. So what is 968 over 960? So let's say, okay, it's over 960. It's 4 over 5. It's 4 over 5. That's 4 over 5. Now here's the question, right? So what do we do whenever we prove? What do we do? Okay, what do we do whenever we now here's the question, right? What do we do whenever we prove for independent event? Now we're able to find the left hand side. Now we have to deal with the right hand side. We have to multiply whatever we see on the right hand side. So what happens? We'll have the probability of males multiply the probability of HIV negative, right? So what do? We'll say, okay, 11 over 20 multiplied by 4 over 5. So what is 11 over 20 times 4 over 5? 11 over 20 times 4 over 5. That's 11 over 25. That's 11 over 25, right? Now what is 11? Now what is 11 over 25? That's 0 comma 44, right? And then I want us to note Now let's check this. What is 2? What is 211 over 48? Now 211 over 480 is 0, 43955 blah 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 blah. And then looking at the second equation, we had not the second equation, but looking at this expression, we have 0, 44, right? So I want you to note that whenever we round this thing to two decimal places, we will have 0, 44, right? And then the moment rounding it to decimal place, why am I doing this? If we check, so we had our left hand side, if you check, we have up to two decimal places. That's the same thing that I do with one, right? So I make them, both of them, up to two decimal places, and look at them, both of them are equivalent to 0, 4. So what does this tell you? This tells you that both events are independent. Therefore, we'll say therefore HIV status is independent. So therefore HIV status is independent of gender. And then I repeat this for the second time, that whenever if you find that they are not independent, you don't say that they're dependent, right? You just simply leave it, right? You will say no, they are not, right? They never asked you whether they are dependent or not. The only thing that they asked was whether they are independent, right? So it's a yes or no question, and then you have to justify. Either you have to justify with the condition or the calculations, right? So it depends on the question, right? Let's look at another contingency table. Let's look at okay. Now let's look at 9.2, right? I'm just going to find a new page. Let's look at 9.2, right? And 9.2, we have a contingency table here, right? Here's the statement. The table below shows data, not okay. The table below shows data on monthly income of employed people in two residential areas. Representative samples were used in collection of the data, right? Here I have my monthly income in rents, and here I have the residents. It's either area 1 or area 2, right? So this is the total, right? So now I have the question, right? So the first question, now we are looking at question question 9, right? Let us look at question 9. So the first part, I'm not going to do the first part, or let's just simply do an entire question since we've dealt with all of them. So the first question that we have 9.1, right? And then 9.1, we are given that the probability of A is equivalent to 0, 4. The probability of B is equivalent to 0, 3, and the probability of A and B is equivalent to what? And and the product of A and B is equivalent to 0, is equivalent to 0, 8, right? So here's the question. Are events A and B mutually exclusive? Justify your answer with appropriate calculation or a diagram, right? So for you to be able to identify as a code, right? Here's or, it's not B, so it's or, it's not and, it's or. So here, for you to be able to identify whether the events are mutually exclusive or not, you need the probability of A and B, right? And look at the question, we were not given the probability of A and B. Now we have to find the probability of A and B by using what? By using the addition rule. So now the addition rule states as follows, that the probability of A or B is equivalent to the probability of A plus the probability of B minus the probability of A and B. So here for the probability of A or B, I have 0, 8 For the probability of A, I have 0.6. For the probability of B, I have 0.3, right? Minus the probability of A and B, since it's not given, right? And now we consider the like terms. So on the right hand side, I will say 0.6 plus 0.3, which is 0.9, minus the probability of A and B. Note that probability can never be negative. What you have to do, you have to transpose this negative probability to the left hand side, right? So the negative probability will become a positive probability. And then on the right hand side, I will have 0.9 minus 0.8, which is equivalent to 0.1. Now the question stated as follows: that are events A and B mutually exclusive? Now looking at the probability of A and B, the probability of A and B is not equivalent to 0, right? So you will say no, they are not. Since what? You will say no, they are not, since the probability of A and B is not equivalent to 0, but it is equivalent to 0, 1. It's not equivalent to 0, but it's equivalent to 0, 1. Now we have that 4 marks. We're done with the first. We're done with the first part, right? Now let us find another page, right, and head to 9.2, right? So what happens, right? So 9.2 reads as follows: the table below shows the data on the monthly income of employed people in 2 residential areas. Representative samples were used in the collection of the data, right? So if we check here, we have 2 events, right? We have the first event that we have is the monthly income and rents, and we have the residence, which is area 1 and area 2, right? Now here is 9.2.1. What is the probability that a person chosen randomly? What is the probability that a person chosen randomly from the entire sample will be from area 1? Now we are looking for the probability of a person coming from area 1. So you look at area 1. This is the entire block for area 1. We are looking for the probability of the people that are residing in area 1, right? So what is the total of area 1? They never said whether they earn this amount or whether they earn this amount or this amount. They just simply said they want the probability of the people staying in area 1, right? And then the total number of people staying in area 1 is this value. So we are going to take this value over what? Because of we are speaking about the probability, we are going to say this value over the sample space, right? So for the first question, our probability will be 1.832 all over 2646. So let's check it out. What is 1832 all over 26446? Right. We have what? We have 916 all over 1. We have 916 over 1, 2, 3. Right? So we are done with the first part, right? That's A. Right? Now we head to B. So what happens about B? So at B, we are looking for a person. We are looking for the probability of a person residing in area 2. So we are looking for a person residing in area 2, but that person must earn less than 3.2 per month. So this is area 2, but we are not considering the whole area 2. We are looking for a person who's earning less than 3.2. Now look here. Here it's a person who's residing in area 2 and any 3.2. So I will say this amount over the sample space, not over the total of those who reside in area 2, but over the sample space. That would be 460 over the sample space. So here I'm looking for someone from area 2 who ends, x less than 3.2, which is 460 all over 264 all over 26446, right? So what is 460 all over 2646? That's 230. That's 230 all over 1323. Right? Now we have C. Now at C, we want a person from area 2 who earns more or equal to 3.2. Who earns more or equal to 3.2. So we want a person residing in area 2 who earns more. So we want the one from area 2 who earns more or equal to 3.2. Here is more or equal to 3.2. That's 340 over. So here in this case for C, okay, for C we'll have 340 all over what? All over 2646, right? Now what is 340? So what is 340 over that? That's 170 all over 1323, right? So we're done with 9.2.1, right? Now we are left with 9.2.2 and 9.2.3. Now let's look at 9.2.2, right? This question is similar is similar to the one that we just did in the previous question, right? Prove that any and income, in this case they're saying prove that any and income of less than 3.2 per month is not independent of of the area in which a person resides. Now they're saying prove that any and income of less than 3.2 is not independent of the area in which a person resides. Now here's the question. The question is simple. Here they're asking you to prove whether the events are independent or not. Even though they're telling you to prove that they are not, right? But you use the same condition. Here they're telling you to prove that they are not, right? So the question is as follows: are these events independent? So whenever they are not independent, you will be proving that they are not independent, right? So now the first thing that I told you to do is to consider the condition, right? We know that for what you consider the condition. So for we know that for independent, so we know that for independent events, the probability of A and B is equivalent to the probability of A multiplied by the probability of what is equivalent to the probability of A multiplied the probability of B. In this case, you are not choosing for your own. Like on the first question, on the previous question, what did I do? I chose, like from the gender, I chose male, right? And then from the status, I chose my own status, right? In this case, you are restricted only here on the monthly income. You are restricted. You cannot choose your own monthly income because here the question is specific, right? So it's specific on an income which is less than 3.2, right? So which means the first thing that we're going to consider is the people who earn less than 3.2. That's the first thing. And then the area, they've never specified any area. You can choose any area. Like I will choose area 2. I choose area 2, right? The first thing that I have to determine is end. So I have to determine the probability of a person who earns less than 3.2 and resides in area 2. So what is that person who earns less than 3.2 and result in area 2, right? So I check, okay, here is 3.2. This is my row for the people who earn less than 3.2, right? So I'm looking for area 2. Here's area 2. So these are the people who earn less than 3.2 and they are residing in area 2. So I'll have, since I'm dealing with the probability, I'll have 460 over the sample space, right? So I'll have 460 over the sample size. What is our sample size? Our sample size is 26446, right? So let's check it out, right? What is 460? Okay, that's 230 all over 1323, right? So now I'm done with considering the intersection, right? Now I'm done with this part. Now I have to determine the second part. What do I do? So A is an independent on its own, the probability of A. So looking at A is an independent, it's an event on its own, and B is an event on its own, right? So now I'll determine the probability of all people who earn less than 3.2, irrespective of the place that they reside, right? So what is the probability of the people who are any less than 3.2? I don't care whether that person would like in area 1 or area 2. I don't care whether the person resides in area 1 or area 2. So I want the total, which is 960. So I'll have 960 over the total space. I'll have 960 over what? Over 2646. Right? So what is that? 960. Let's check. That's 160. So that's 160 over 441, right? And then on the second line, what do I do? No, I consider all people who reside in area 2. So irrespective of whether they enter pen 2 or I don't really care. Now I want all people that resides in what? I want all people that resides in area 2. So I'm going to consider the total number of the people who resides in area 2. So this is the total number of the people who resides in area 2, which is 814, which is 814. So which is 814 all over what, which is 814 all over 24, which not 24s but 2646. So what is 814? Okay, we have 81426, right? So I will have what? I will have 407 all over. I will have 407 all over 323, right? So I'm done with the left hand side, like I said. So now I have to determine the right hand side. So I have to multiply these two probabilities, right? So I will say the probability of A multiplied by the probability of B is equivalent to 160 all over 441 multiplied by 407 all over 1323. So what is, so let's check 160 all over 441 multiplied by 407 all over 1323. Let's check it out. I get 0,11161 blah 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 blah, right? And then let's round off this one, right? What is 230 over 1323, right? What is 230 over 1323. Okay, let's that's 460. Okay, what is 460? 460 all over 2646. Okay, that's 0 comma, that's 0 comma, that's 0 comma 17. And here that's 0 comma 7173 8 blah blah blah. Looking at these two numbers, no matter how you try to run them off, they will never be equal to one another. So here's the probability of A and B, here's the probability of A times B, right? And in this case, if you check, like, these answers are not even closer to one another. Therefore we know that any an income of less therefore we know that any an income of any an income of less than 3.2 per month is not independent, because if these two values were equal to each other, we were going to say any an income of less than 3.2 is independent. But because of these two values differs, we will say it's not what is not independent. It's not what is not independent of the area in which a person the area in which a person resides. The area in which a person resides. Right? Now we have the last question. Let us deal with the last question. Right? So what happens on the last question? Which, okay, that's saying which is more likely, a person from area 1 any less than 3.2, or a person from area 2 any less than 3.2? Show the calculations, right? So which is more likely, right? So we want to know which is more likely between the two. So we are in actuality we are determining, we want the one with the highest probability, right? That's why they say which is more likely between a person, which is more likely a person from area 1 any less than 3.2, or a person from area 2 any less than 3.2. So we consider any less than 3.2, right? So any less than 3.2, looking at area 1, will have any less than 3.2 will have 500 all over 2646, and any less than 3.2 but the person resides in area 2 will have 460 all over 2646. Now let's look at these values, right? So we'll have 460. We know that 460 is 0, 1738473 right? And then for the first one, it's 0, 18896444747. We know that looking at the first one, the first probability is greater than the second one. Therefore, the person which one is more likely? The one who is more likely is the person who resides in area 1, and that particular person will be any less than 3.2. We will say the person, therefore the person who is residing in area 1 any an income of less than 3.2 is more likely. Now we have another equation. Let us look at the last question. Right? Let us look at the last question of our session. Right? So now we have question 9. Right? On this question 9, okay, we are looking at 9.2 in this case. On a flight, passengers could choose between a vegetarian snack and a chicken snack. So the snacks selected by the passenger were recorded. The results are shown in the table below. So we have two kinds of events in this case. We have the snack, and then we have the gender, which is female or female, the snack being vegetarian snack or chicken snack. So the question states as follows: Was the choice of snack on this flight independent of the gender? So the question, this is like they're just simply trying to play with our mind, you know. Looking at this particular question, this is the same as asking whether these two events are even whether these two events are independent or or not, right? So what happens is that the first thing that we do, I said you choose, right? From the snack, I'm going to go with chicken, right? And then for the gender, I'll go with male. It doesn't matter what you choose, right? And the first thing that I determine the intersection of chicken and male. So what is the probability of the males? This is the probability of the males that each chicken. I know 55 males each one chicken. I'll have 55 over 1/5. So in this case, I'll have 5 over 1/5, right? And now I consider the probability of what? Now I consider the probability of those who eat chicken only, irrespective of the gender. I want chicken. The total of the chicken is 1. The total number of the people who eat chicken, it's 118. So 118 over 1/5. So 118 over 1/5, right? And then the other thing that I consider is the probability of maize, right? So what happens is that on the probability of maize, now I want the total number of maize. That's 67 over 1/5. So I will have 67 over that's 67 over 1/5, right? Now let's calculate this. Let's simplify this values. We have 55 over 150. We have 55 over 150, which is 11 over 30. Let's try to that's that's 0,366 blah blah blah, right? And then we have the second part, right? And then do not forget that you have to state the condition. You will state for independent, for what? For independent, so for independent events, note that the probability of A and B must be equal to the probability of A multiplied by the probability of B, right? So what do you do in this case, right? We were able to find the left hand side. Here's our left hand side. We are only left with the right hand side, right? Now what is the probability of C multiplied by the probability of L? So we'll say 118 over 150 multiplied by 67 over 150. Now let's calculate. So what is 67 over 150 multiplied by 118 over 150? That's 0.35. That's 0.35 1 the 0.35 3 1377. Sorry with this. Okay, that's 150. So now I want you to note, right? We have 0.366 and here we have 0.5. If I try to round these two to two decimal places, what do I get? I get 0.4 on this side, and here I get 0.4. But in this case, that's not true. Why am I saying this? I want you to note that you will only round off whenever one of the answer is 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 close to to few decimal place. What do I mean whenever I'm saying the answer is close to? So on the first equation, what did I do? On the first equation, I rounded the second answer because of the first answer. Right, the first answer was was to two decimal places, right? Therefore, I had to round. But looking at these two are not equivalent to one another. So I will only round off. I will only listen to this. I will only round off according to you only round off according to the first answer. So if both answers are different and both of them are long, you just simply both of them are different and long. You can never you can never round off and try to equate them, right? Meaning this thing is invalid, this thing is invalid. These two numbers are not even closer to one another. Only if this was, maybe we'll say 0.4 and then we round the other one to be 0.4. Therefore, you are permitted to do that. But in this case, this we have two different answers, right? These are two different answers and both of them are long. You cannot round them and try to duplicate them to one another, right? So in this case, we'll say the choices are not independent of gender. So the choice of snack is not independent of gender. So the choice of snack is not independent of gender, right? Now we have the last question being 9.2, right? 9.2 is our last question. So 9.2 is our last question, right? So what happens on 9.2 is that we're given two events A and B, right? And it is given that the probability of A and B is 0.12. The probability of A or B is 0.83, and the probability of B is 4 times the probability of A. Now, the first question is as follows. Are events A and B mutually exclusive? Justify your answer. So, we want to know whether events A and B are mutually exclusive. So, what happens? The first thing we know that we consider the probability of A and B. So we cannot say they are mutually exclusive since the probability of A and B is not equivalent to 0. Therefore, we'll say no, they are not mutually exclusive. Why are we saying this? We are saying they are not mutually exclusive because the probability of A and B is not equivalent to 0. In fact, it's equivalent to 0.1, right? So we are done with 9.2.1. You get full marks. Now let's look at 9.2.2. 9.2.2 we are asked to determine the probability of what? 9.2.2 we are asked to determine the probability of B, right? So how are we going to determine? We use the addition rule. You use the addition rule and substitute whatever is given on the statement, right? So we'll have the probability of A or B being equivalent to the probability of A plus the probability of B minus the probability of A and B, right? What is the probability of A or B, if I may ask? The probability of A or B is given in the equation is 0.83, right? And the probability of A is the probability of A is not given, right? We'll have the probability of A since it's not given. And we were told that the probability of B is 4 times the probability of what? It's 4 times the probability of A minus we were given the probability of A and B being 0, being 0, 1, 2, right? What do? We consider the like term. So I'll have 0, 0.83, and then what is, we know 1 plus 4 is 5. These are like terms, so we'll have 5, the probability of A minus 0, 0.12. Since we are looking for the probability, we'll be left with 5PA, and then we will transpose 0, 0.12 to the other side to be positive 0, 0.12 from negative 0, 0.12. Now when we add the two, 0, 0.83, when we add 0, 0.83 plus 0, 0.12, we get 0, 0.95. We get 0, 0.95. We are not done. What do we have to do? We divide both sides by 5 since you are looking for the probability of A in this case, right? So we get, okay, 0, 0.9, okay, let's say 0, 0.83 plus 0, 0.12, okay, and then we divide by 5, so we get 0, we get 0, 0.19. Now what is the probability of B? From the statement we were told that probability of B is 4 times the probability of A. Since we have the probability of A being 0, 0.19, we will substitute 0, 0.19 where we see A. And what is 4 times 0, 0.9? 4 times 0, 0.9 is 0, 0.76. That's 0, 0.776. You see, now we are done with 9.2. We are only left with 9.2.3. So what happens at 9.2.3 is that you are asked to determine the probability of not A. And I told you whenever they say not A, you say 1, you minus, and then what do you consider? You consider A. You will say, sorry, you will say 1 minus, what is A? A is 0, 0.19. So what is 1 minus 0, 0.19? So 1 minus 0, 0.9 is 0, 0.81. Perfect. We are done. Students, I believe we are done for the day. We'll have the last session for probability, which will be based on tree diagram, and we'll dwell into some questions, and then we'll have a revision session for the entire worksheet of probability, consisting of all aspects of probability, being Venn diagrams, contingency table, as well as the tree diagrams, including those events as well. You see, so this content for this session caters for the grade 11 as well as the grade 12s, because when I check grade 11 is 80p. It's everything that it's everything which is in grade 11. So the only thing that differs is counting principles, and we'll have a session on counting principles. This is where I'll be limiting the grade levels from watching that session. Cheers. Bye.